Okay guys, today in this video we are going to learn about the success of classical free electron theory, its drawbacks, and some of the difference between classical theory and quantum theory. Okay, let us start from the success of classical free electron theory. Okay, the first success of the classical free electron theory was this is verified the Ohm's law. It verified the Ohm's law was the first success of classical free electron theory. It explained electrical conductivity of metal. It was the second success of the classical free electron theory. It explained the electrical thermal conductivity of metal. These were the 3 points. I have separated them in 2 points. Okay, verify Ohm's law, electrical conductivity, and it explained the thermal conductivity of metal. It also explained the optical property of metal, like how metal reflects the light and other things. Optical property of metals are explained here. Okay, after this success, like the verify Ohm's law, electrical conductivity, thermal conductivity, and the optical property of metal, we are going to ask the drawbacks of classical free electron. Okay, I have changed the highlighter. Now we are going to study about the drawbacks of classical free electron theory. Now, the classical electronic theory was unable to explain the photoelectric effect, Thomson effect, etc. Like it is not able to explain the photoelectric effect and this Compton effect. Okay, after that it is okay, let me correct the mistake here. CON conductivity, CON conductivity. Okay, it could not explain the electrical conductivity of semiconductor and insulator. As we know that it has already explained the electrical conductivity of metal, but it is unable to explain the electrical conductivity of semiconductor and the insulator. Okay, now we are going to ask the third point. It could not explain why some metal only prefers certain structure. It is unable to explain that why some metal only prefers certain structure, like Fe iron. It only prefer the certain structure, because many of the metals prefer many structures, but some of metal could not prefer. Some of metal could only prefer certain structure. So it could not explain why some metal only prefer certain structure. Okay, now another point was like that none of the crystal behave like the metal, but some of the crystal in exceptional case, like I don't know the example, but some of the crystals behave like metal in nature. So it could not explain why some crystal behave like metal in nature, why some crystals are metallic in nature. Okay, it fails to explain the semiconducting property of matter. It is success in explaining the electrical conductivity, but it is failed in explaining the semiconductivity property of matter. Okay, now we are going to learn about some classical theory and quantum theories differences. Classical theory versus quantum theory. Okay, but we have now studied totally about the drawbacks and the success of classical free electron theory. Now we are going to study about the differences among them. Classical theory and quantum theory. The first difference is, okay, now the first point was the electron behave as particle. The classical electronic theory says that the electron behave as particle, but quantum theory doesn't say. Quantum theory says that electron behave as both wave and particle. And second difference was the classical theory follows the Newton law of motion, but the quantum theory follows the Heisenberg uncertainty principle. Okay, that was the second difference between both of them. And the main difference between classical theory and the quantum theory was that it is applied to macroscopic body. Macroscopic body are bigger than the microscopic bodies. Okay, the quantum theory is only applied to microscopic bodies, like which can only be seen through the microscope. And the classical electronic theory says that energy is not quantized quantity. It is totally wrong. That the quantum theory says that the energy is quantized quantity. So this statement is true here. So these are some differences between classical theory and quantum theories. Okay, these notes are totally exam based, so you can learn from this. These are so much short notes. Okay, I'm going to give you the screenshot in the description. Okay, best of luck for examination. Thank you for watching the video.